Okay, today is the last day of May, and now we have 13 minutes left. And let's scroll to our last question for today and for this month. So it is search suggestion system. It seems hard. And this is question number 1268. So it is a medium question and have 1200 upvote, and I checked, I have submitted this before. So yeah, I submit twice on the same day. I don't remember why, but yeah, let's try to see if we can solve this problem. But it looks hard. Okay, so let's read the last question of May together. So it's search suggestion systems. Given an array of string products and the string search word, we want to design a system that suggests at most 3 product names from product. After each character of search word is type. Okay, suggested product should have common prefix with the search word. If there are more than 3 product with common prefix, return the 3 lexicographical minimum product. Return list of suggestion product after each character of search word is type. Okay, so we have a mouse. I think I remember this. Oh my god, we only have 13 minutes. I'm not sure if I can do this though. So mouse, this is when you type M, and this is when you type MO, and this is when you type MOU. Right? So the third one got removed because it's not MOU. And when you type MOUS and when you type MOUSE, product sorted. So you sort this first and then you type MO, you got match for this, and then all those. Okay, I think I remember this. I remember I tried to use try to solve this, so I actually end up typing a lot of code, and then afterward I think I saw the solution, and somebody used a really weird, intuition. That's something that I won't think of. Like, they append the tilde on the end of the search word and then search it. Yeah, and I don't remember how that works. Yeah, the only thing I remember is the tilde. Oh, there are hints. The only thing I remember is that when they try to search MOU, when they type MOU, I remember they tried to search MOU and MOU tilde. I guess that's because of the ASCII value is CII. Where is the tilde? So it's smaller than those. So I guess any other works, right? This or $sign or anything should work, or star should work. Yeah, but I don't remember how that works. So if I would try to type a lot of code using try, I don't know if I can solve this before the deadline. Let's try to see the hint. Brute force is a good choice because the length of the string is less than... Oh, really? There are no repeat elements in product. Okay, and then all the product length will be less than this, so that's all the string length in the product. Okay, all the character of our lowercase. Okay, and the search word will be less than 1,000 length. All the character in the search word are lowercase. Okay, so binary search the answer. Yeah, that's what I remember. Use try structure to store the best tree matching traverse to try. Yeah, I remember I used to try because, like I said, I'm not good at binary search. So if I could use try, not binary search, I will use try. But I remember this, just typing the try is a lot of code. And then when I saw the solution using the search, it's actually pretty short. Should I do try? Let me do try. So let me do a 26-way try. And then once I reach that point, I will have a sub helper function to find the first three. And then I do another one. I have the search function to do the three. Have another one to do the search function to do the three. Okay, let's try the try. The try is that because we are typing, for example, MOUSE, so when I type M, I move the M into the try first step, and then I have a help function to find the first three, and then back to the try function, and then go to the MO, and then helper function find the three, and then go to U, helper function. So that's my plan. Let's see if I can code those. So I will have a try, and I don't really remember what I should do. So try will have a try array. Let's say child, and I will have a Boolean. Do I just need a Boolean? Or or do I just put the word in here so that it will be easier for me, that I don't need to carry around a string builder? I don't know. Boolean should be fine. Is that it? Okay, so when I new a try, I will have child equals to new try 26, and then is word is false. Well, it's good that I have a chance to practice try anyways. So now I have this. Let's do the insert try. So do we have any special case? Like my result is list of strings, so I will have a list of string res equals to new array list. This is something that I need. And then do I check if the search word is empty? No, the search word will not be empty, so I don't need to check it. So let's do for each string s in the product, products. So for each string in there, let's do the insert word. So what we are going to have a root, right? So try root equals new try. So we now have a root. So I will insert the word and the try and the current level. I guess that's it. So now my cat is here. Hey. Okay, so now let's implement the insert word first. Oh, my cat. Oh, don't bite me. Okay, then let's sleep. Lay down. Okay. Okay, so let me implement private. Oh, do I have time? Where am I? So this insert word could be void, right? I don't need to return anything. So I will have a string s, and I will have a try node, and I will have a int cur. So how are we going to implement it? I will probably do a recursive call. Okay, so now that I'm here, if cur equals to s.length, so we reach to the end of the word, and we are going to do a node dot is word equals to true, right? And then we return. I guess that's it. We don't need to do any other things. Otherwise, we are going to continue. So if we are going to continue, let's do a as the char at cur, right? Let's get it into integer, and index equals to this. I got the, and it's lowercase, so I can, so this how I got the index to integer. And if the child is null, so if node the child index is null, let's new try for it. Okay, so new try, and then let's just do the recursive call, right? Is that it? So I will do the cur +1, and I will do the node and the same as. So that's probably our insert word. Hope that works. I only have 15 minutes left. Okay, so now after I insert it, I will start searching for the word, right? So like search SEAR or type. Let's just make it search is probably better for a try, although we know we are going to search type, I mean. So search word. So what are we going to pass? we are going to pass, of course, the search word. And of course, we also need a root. And we also need a cur. What do we need? I will need a string. Hey, hello. Sorry, I didn't see the chat because I'm kind of nervous. I don't know if I can do a try in such a short time. But anyway, I might need to cheat to submit and then retype again. Okay. Search word. I will probably need a string builder because I need a string. What else do I need? I need to pass in the res, right? So that I can append. I guess that's it. And then we return res. Okay. Now we need another thing. Private. Search word. We probably don't need to. Maybe it's void too. Let me do it. Search word. Anyway, string. Let me just use s. And then let me call it try node. And this will be the current in current, right? And then we are going to have a string builder SB. And then I will have a list of string. Okay, I hope that's it. So again, the same. If we reaching to the end, so if cur equals to s.length, so what are we doing? We are not doing anything, right? Hold on, so we are searching the current, I'm a little bit confused. So we are searching the current cur. So when I, for example, mouse, when I have the mouse, when I reach to the end, currently I have a mouse, right? Previously I go into E, and then so I go into the E child, and now I reach to the end. I don't know. Let me put this on hold. So let me do the same thing. I probably need a char. So I need a char because I need a string, right? I probably need this. And then I will need the index too. So I'm a little bit confused. And so for example, now after root, I'm getting the M for mouse, right? And then I am going to, so now I am root. And then I have M. I don't know if it's already. What solution you use? Binary search? I mean, binary search is probably shorter and easier, but I'm not good at binary search though. Okay, and now try is confusing me. So now that I have a root and I got the first character, do I need to go to there first? Or I start searching the 3 word from here? I have an M. Right, so if the next one is M. So do I start search? So I start searching from M, because M itself could be a word. So from M. Uh, 8 minutes left. I might probably need to cheat. Let me get ready for cheating. I think this one is the... Yeah, this one was my previous solution. Wow, that's so super long. Oh my god. Oh, yours is... What are you trying to do? Oh, Python is super short. Oh, you use start with? Okay. I can probably use start with because there is a start with in Java too. So that's why I'm confused. Should I really use a try? I mean, if not, that they also mentioned trying here, I probably will not even do a try, because a try for me now is so confused. So now that I have this, do I go to a trial first and then start searching? Do I? Yeah, I probably need to go. So if I go to the child and start searching for the 3 words, okay, anyway, so, but what if the child is null? I mean, what if there is no such... You mean time complexity? Probably. Maybe not, but maybe space will be better. But time complexity should be the same. Or maybe even worse. No, but because use try, you don't need to actually sort it. But if you are using start with, then you need to sort it first, right? But use try, you don't need to sort it though, because it will be naturally sort if I use a 26-way trial. So I am probably gonna need to... Okay, confused. Oh, so if... Okay, I don't want to cheat, but it looks like I do need to cheat. I'm running out of time. Because I am confused in here. Do I search in current level or I search in the child level? But what if child is null? Because I only need to find the, so type the suggestion that we common. Oh, you need to have the common prefix, right? So I think when you type M, I actually go to the child first and start searching from there. So now I know the next character. If it's null, then I will return. Okay. A little bit confused. Maybe I don't even need a help search function. So if if this is null. Hello. I am only 2 minutes left, so I will probably need to use my previous. Oh, my previous was, yeah. I guess my thought process was the same. So I find the word and then I get the 3. Yeah, but I am confused about the find word part. Anyway, I don't have time. To be safe, let me submit first. And then let me come back to here. Okay. 5 word? What's 5 word? Oh, find word or search for word. Sorry. Yeah. So now I'm going to use a try, right? So if the child is null, then do I just put, okay, so I will just put an empty rest dot add a new array list list of string sting. But else I will call get 3, and then how do I continue? When you reach the inner node, do a leaf traversal and output. Yeah, that's what I think. But, well, that's my weakness about doing a try, though. I always confuse about the leaf part. For example, now that I'm in the root, you can just keep the suggestion in the try now. Yeah. So I will keep going, right? So I will probably recursive call or don't, or and then take the first 3 in the sorted order. Yeah. So because I think, for example, doing the insert word is easier because it's a recursive call. But now that I'm searching word, I probably don't, don't do the cur and use a recursive, right? Because I am going to have Yeah, so I will probably just do a while, like while, yeah, so I probably don't need this curve. And then take the first 3 in the sorted order. Yeah, so my thing is like this. I always confuse myself about the leaf. And for example, now I'm currently have a root, right? But root is actually empty. So my first character is the child of the root. And then I will got confused. So where do I start searching? Like, yeah. Okay, so I think for the search word, I'm going to do the iterative call, not the recursive, because it will confuse me more, I think. Or maybe I can, yeah. Time to start June. I haven't even finished the May one. Maintain a list of the indexes of the word in each node. Maintain a list of the indexes of word in each node. Oh yeah, I know, but I choose to do well, if you try to do that, then you can do that in the insert word, right? So while you are returning, you can just put the 3 list in there so that when you do the search, you don't actually need to search the 3, right? So when you insert, oh, today's daily, I'm still on yesterday's daily. So when you insert the word, yeah, can you also put the the 3 in the list and propagate it back? Yeah, can I do that when I'm inserting? Probably not, because when I was inserting, there is no order. So it looks like if I want to maintain that list, it's better that I do it after I insert everything, right? So yeah, I still need to store the word. Oh, you mean when output? But when output, because it's a try, I don't need to sort it. Yeah, well, I'm stuck in here. Should I do a recursive or a iterative? Which one is easier? I think recursive is a little bit easier for me. So it's like every time I reach the child, I start to do the get 3. And then I move to the next, right? But then root, I don't need to do the get 3 because root is nothing there. So I should do a child. Okay, let me do iterative. Let me cheat on what did I do last time. I think I do. Oh, I search word, refine word. Oh, that's not what I don't think this is good. So I don't want to do whatever I did last time. Yeah. I will do iterative, I think. So for each character in there, I move toward the try and get 3. Okay. Let's do iterative. So iterative is for int I equals to 0, I smaller as that's the length, I plus plus. So if I were to do the iterative, and then I will get the current, and I will do the index. Index I probably don't need it yet. I'm confused myself. So the thing is, if ever the child is null, then from there to the end, it's just empty string, right? So I want to do this. So I think, oh God. So I want to do if this is null, then I'm not sure if this is correct though. Then I will add an empty one into the rest, and then I will have a not found FOU and D is true, and then continue. And then when I start, if not found, then I will just keep continuing. Is that right? Because I like this one. So no matter because you will reach to a point that there is no same prefix anymore. So every more thing that you type will just return an empty list, right? So I think I can do this, right? So once the first time that empty child is found, I first insert an empty string, and then I set this flag to true, and then I continue. And then I do the same thing until the end of the string. Okay. Otherwise, I am going to so if I reach to this point, which means that I have the child, right? So let me do the sb.append c, and then I will call a get 3 from the child node, and then I need a 3, and then I have the sb, and then I will pass the rest. Okay, I don't even know if that's correct though. It's so weird. Okay, so after I call the get 3, I will continue the for loop. Node will equals to node dot, and I will continue the for loop. Is that logic correct? Okay, so if the child is not null, if it's null, then I don't do anything anymore. If it's not null, then I append this to the SB, and then I call the get 3 on the child node, and then this 3 will be append to the rest. And then I will proceed to the child. And then if I need to do a private void get 3, and what do we have? I will have a try node, and then I will have how many left, and then I will have a string builder SB, and then I will have a rest. Wow. I know the try concept is probably easy, but I got confused a lot by just doing a try. Okay, now what I'm going to do is if cur equals to like 0, which means I already got 3 words. I return, right? So, but there could be 2 words returned. So what's the status of 2 words returned? So for example, we type MOU, and after MOU we only got 2 words. So it's that we do the DFS or anything, traverse every word, and then we return. So oh my god, my cat is moving my camera again. Come on. Okay. So I start doing here to do a DFS. Or should I just do recursive? Okay, so anyway, let me just do a DFS. So if if the current node is word, if it's word, then I will no, I probably need a new, oh, I'm so confused. New array list of string. Okay, so I will have a cur. So that's cur. Because I need to put things into the cur and then later put that into res. Okay, so if it's word, then cur dot add sb dot to string. Okay, now I go to the child. So for int I equals to 0, I smaller than 26, I plus plus, if node child I is not null, then can I call it recursively? Get 3 node child I, and then count -1, and then I should -1 in here. So count minus. Okay. So probably I don't need count. I don't know. So I'm thinking this is not a DFS. This is a backtracking, because for this I will have to sb.append char A plus I, right? And then I can put SB into there, and then I can put the cur into there, and then I will put res. And then after it come back, and there is a problem though, I don't return the count back. So how do I know after I call this how many? Right, so I probably don't even need a count. So okay, I will remove char at sb.length. Okay, so this is like a recursive call. So when do I return? It's either count equals to 0. Maybe I don't even need a count, right? I can just check the cur length. So if cur the size equals to 3, then return. So if it's not null, so let's not do the count. But if I do a recursive, when do I? Okay. So now everything is adding to this. I'm really confused. So this is sort of a, so I probably don't even need res. So I will just do a get3, and then after get3, my res will be add cur. So I don't need this. So I don't need to know. I struggle with the try the solution if I got it right. Oh, really? You got your try? Cool. And I'm still doing it. So, okay. Okay. So I'm really confused myself. So I call the get3 to put everything into this. So I will need a array list of string. Temp. And I passed in this temp, and then I res add temp, and then I go to the next one. So is that right? I'm so confused. Line 2. Oh. Oh. $61. Cannot find simple remove char at hold on, stream builder. Do we not have okay, I will check your resource. Let me click it so that I won't forget. It's slower, yeah. Well, my pass, this is used more of a naive one, and this was using a try and then try slower. So I don't know why. Let me think about that later. But I want to search for stream builder. How to remove a... Isn't that remove char at... delete char at... Okay, not good, not good. Why I only get the first one? Oh my goodness. Why I only get the first one? So when you type MOU, so when I type M, it works. I got the 3. And then I move to the child, and then I come here. And it's not this. And then do I... why do I have a cur? So I'm doing a recursive or iterative, so it's I, right? So what's cur? Where do I have the cur? I don't need the cur, right? Okay, let's try again. Finished. So how many test cases we have? I don't know if that's correct though. Not yet. Havana. I will check your answer later, because you did 2 different solutions, right? So I only did one, and it already got me so confused. Okay. Show diff. So it's probably correct. So should I submit? It's already late. Okay. Now to the point of why it is. Okay, let me check your solution. Yeah, everybody when doing the try, it is so long. You can put multiple test casing. Oh yeah, you could. And then it's actually easier if you do it in here, because in here, like let me paste my code in here. So in here, the run code, oh, it was blocked by me. Hold on. Now you can see it. The run code here, you can run example test case, right? So it will be easier than you manually put the test case in here. So I usually just run it through here. And then in the contest, they can do multiple too, but in the daily challenge, they don't offer you the button of putting all the test case in there. So you have to copy and paste by yourself, one by one in here. So I usually just copy my code into the regular problem section and then do the run code in here. Great. Glad that helps. And then, yeah. So so even for Python, if writing in Python it's already let down, I feel good that mine is super long. So because even using Python, you cannot avoid typing so many codes when doing a trial. So yeah, you have the node and then you have 24 and then you have this and you have a character in there. Okay. So you add child. If it's null, then you create it and you return this and you get child. Okay. So you start by having a root and then for each one character you go add it into there. Okay. So you call this to add those product into the tree. Yeah, but you still, I don't know, I just think that the way that you write it is, well, compared to mine is like a mess. And then you do a DFS together 3 words, right? Yeah, so you define that in here. And for C in search word, if not, then you append, continue, and then you get a child again, and then you do the DFS. Cool. So when do you get a child? So for each word, okay, my cat is blocking my screen again. Go. Okay, you get a child and then you do a DFS for each character in the search word. Okay. Yeah, cool. So compared to mine, I think my code is a little bit, oh, my cats. Come here. Okay. Yeah. So the solution that I said was probably from Lee215. So he's doing a binary search. So he sorts, so I guess that's what you do too, right? You first sort it and then you do a start with for each product. So, and that's why it says in the hint. Yeah, but the solution is not written. He's using other people's Java solution, so I just took that solution, I think. So that's the hint one, right? So brute force is good choice, but actually it's not brute force. You actually sort it, but it's still because it's only 1,000 words and length is of the search word is only 1,000. So if you search it, sort it, and then use the start with to compare, and then when you reach 3, then you get out. It actually works. So I don't know, but somehow I it's hard for me to do this too. Like, yeah, that's what he did in here too, right? And then for Java code, he actually took some code from this user, and then for the Java, it's so for the Java, he's not doing the binary search. He directly used a tree map, a red-black tree, to find the previous and the next. So that's the tricky part that I think. So how do you think of this? And then you use the ceiling, use the floor, and because you add this to the string, so when you are getting the floor from the tree, you actually won't get the one that's not a prefix. So this is the trick that I think I will never come up with. So, yeah. That's why, even though I'm doing this again, I still use the try, because the try is more intuitive for me. But it seems like, let me check the time. Wow, my code this time is even slower. Hold on. Yeah, wow, that's a year ago. Okay. Yeah, so it's even more memory and slower than my previous try solution. I don't know. So try is probably too slow. But did anybody like... So if you are sorting, you have n log n, and your space is also on the sorting part, right? But if you are using a try, if you are using a try, what's the time complexity? Why the time complexity is that bad? Because if you are using a try, the time complexity is the length of the string array times the average length of the string, right? Or big O, you should take the worst case of the string. Is that why? Because the time complexity, if a word is 1,000 length long and the string array is 1,000 long, it becomes 1,000 times 1,000. But if you are going to sort it, it's 1,000 log 1,000, so it's pretty much better than the try. Is that the reason why? I don't know. So the try's benefit is only the space, right? It's only the space. But in here, you don't see the benefit because everybody was just sorting in the original array. So they are not wasting any space. Well, of course, Lee215 count the time for sorting and the space for the sorting. Yeah, so I don't know what's the benefit of try. So the benefit for me, of course, it's just try is easier to come up with when you are comparing a character inside a string for two string. For me, every time, if I don't know how to do it, I will just use a try. And also, because if the dictionary is very big, using a try actually saves you a lot of space, right? Because the worst case is that every layer you have 26 child, and then the depth of the child is the longest string in that string array. So it's bounded by the longest string in the string array, not the size of the string array. So when you have a very big dictionary, using a try is good. But in our case, in this one, the constraint is that it's 1,000, so you won't see the benefit of a tree in here. So not tree, try. So our try is actually slower than the sorting solution. Okay, so I probably should be courageous enough to try binary sort, but every time when I see a binary sort, I will just try to avoid it, because I got confused about binary sorts even more when doing a try. Try is simpler for me. Okay, so I can't help, before ending the stream today, I can't help but want to check the new June. So do we again have two questions? Yeah, again we have two questions. Penthouse, max area of island. According to Chris, these two are easy. I don't know. Let's see if it's easy tomorrow, not today. Well, today, because technically we are into the June challenge, the June 1st already. Okay. And then do I get a badge? Do I get a badge? Did I get it? Yeah, okay. So I only have 5 badges. So it's January, February, March, April, May. So that's it. Anyway, but I am happy enough. That's good enough for me. Okay. So I guess thank you for watching. And what I've learned today, I actually didn't learn much today, because I still try to avoid the sorting and searching, or start with. I don't know. I also try to avoid this start with, because every time I use start with, I don't know why I messed up. Because when everybody else think this is easy, this is actually harder for me. I don't know why. And also the binary search, it looks like hard for me too. So I choose the easier route to implement the try today. And yeah, that's too slow. Yeah. So yeah, but it's still, for me, it's still a good practice to do a try. I don't know if that will ever happen in the interview, that somebody is giving you a try problem, because try is, I think try is a little bit easy to implement, the basic try. Especially when I'm using recursive call to do a try, it's easier for me compared to the iterative. So yeah, I really didn't practice a lot. I practiced a recursive call way to implement the try today. And we also know that the time complexity is not so good when the dictionary size is too small. Okay, so that's what I learned today. Hope you learned something today too. So it's a good time to end the stream today for now. And let's have a good sleep. Thank you for watching. I will see you tomorrow for a new month, a new June daily challenge, LeetCode challenge. So I will see you tomorrow. Thank you. Bye-bye.